Pressure is at the core of drilling calculations. Pressure, simply put, is force per unit area, as everyone knows. That is, for a unit area, force applied. If you apply a force F on an area A, then pressure will be force divided by that area. In context of drilling calculations, uh, we should understand it in terms of mud. You have a well, vertical well. For simplicity, take a vertical well and it is filled of mud. One thing you know, as you go down the depth, pressure increases. Why? You can tell that the mud above that depth increases, weight of the mud above that depth increases, so force increases and consequently pressure increases. As you go down, pressure increases. To define such things, that how much pressure is increasing going per unit depth, we have defined a quantity pressure gradient, which is very useful for further pressure calculations. So what is pressure gradient? First, understand what is gradient. Gradient is, or for any quantity, it is the change in that quantity for increase in some distance. For in terms of pressure, it is increase in pressure. Pressure gradient is increase in pressure for per unit increase in depth, and here depth is vertical depth, true vertical depth. For API units, I can write that increase pressure gradient is increase in pressure in psi, pressure in psi per foot. Psi per foot, its unit will be simply psi per foot. Increase in pressure in psi per foot, increase in depth. To understand the pressure gradient, let's take an example. For example, I have a mud system whose pressure gradient is 0.62 psi per feet, which means for every feet increase in depth, pressure increases by 0.62 psi. If I ask you what will be the pressure at 1000 feet, so if for 1 feet pressure increases by 0.62 psi, for 1000 feet it will be 0.62 multiplied by 1000, that is 620 psi. So at a depth of 1000 feet with the pressure gradient of 0.62, pressure will be 620 psi. Conversely, pressure gradient can be used if you know pressure at any particular depth, like 1000 feet, and I ask you what is the pressure at 500 feet, so you will minus the pressure of 500 feet. So this pressure gradient can be used to find pressure difference if you know the difference in TVD. So pressure difference will be equal to pressure gradient times the TVD difference. So pressure gradient is very useful for pressure calculations. It makes things very easy. To see more uses of pressure gradient, I will take up some examples, and in different examples I will take uses of pressure gradient. See you there.